The launch of the James Webb Space Telescope may now provide the data needed to evaluate one of Stephen Hawking's most divisive theories, that dark matter, the invisible substance that makes up most of the matter in the universe, could be made up of black holes formed in the Big Bang's early moments. So in today's video, we'll take a look at the telescope, talk about the theory, give you some updates on the telescope, and more. Dark matter makes up more than 80% of all the matter in the universe, yet it has no direct interaction with light. It simply floats around, massively influencing the gravity of galaxies. It's tempting to believe that this enigmatic matter is caused by black holes, because black holes are notoriously dark. Populating a galaxy with them might hypothetically explain all of the dark matter discoveries. Unfortunately, black holes only emerge in the universe after enormous stars die and collapse under the weight of their own gravity. Making black holes involves a large number of stars, which requires a large amount of normal matter. For computations of the early universe, where the first hydrogen and helium were created, researchers know how much normal matter there is in the universe, and there isn't enough normal matter to account for all of the dark matter discovered by astronomers. That's where Hawking came in. He proposed in 1971 that black holes emerge in the chaotic atmosphere of the Big Bang's early stages. There, pockets of matter might attain the densities required to form black holes on their own, overwhelming the universe with them long before the first stars twinkled. While the concept was intriguing, most astrophysicists were more concerned with discovering a new subatomic particle that might explain dark matter. Furthermore, theories of the genesis of primordial black holes run into observational problems. If there were too many in the early universe, the picture of the residual radiation, known as the cosmic microwave background, was altered, CMB. As a result, the idea could only be used when the number and size of ancient black holes were very small. Otherwise, it would clash with CMB observations. When the Laser Interferometer Gravitational Wave Observatory discovered the first pair of colliding black holes in 2015, the notion was renewed. One theory is that two black holes were far larger than predicted, and one theory is that they originated in the early universe, rather in the dying star's cores. Three astronomers have now produced a hypothesis that not only explains the presence of dark matter, but also the appearance of the universe's biggest black holes. They said that numerous new pieces of equipment, notably the James Webb Space Telescope, which was just deployed, might have the data needed to finally examine Hawking's renowned theory. As we know, black holes emerge only after enormous stars die and collapse under the weight of their own gravity. Creating black holes requires a large number of stars, which requires a large amount of normal matter. From computations of the early cosmos, scientists know how much normal matter there is in the universe. They think, however, that there isn't enough normal matter to produce all of the dark matter, which accounts for more than 80% of all the matter in the universe. So Stephen Hawking proposed explaining how pockets of matter could reach the densities required to form black holes on their own, flooding the universe with them long before the first stars twinkled. He further speculated that these primordial black holes may be the source of dark matter. Astrophysicists at Yale University, the University of Miami, and the European Space Agency, ESA, adjusted the famous psychiatrist's theory and came up with a new model for how the early universe could have arisen. According to the new concept, the earliest stars and galaxies would have formed around black holes, which may have developed into supermassive black holes by dining on nearby gas stars or merging with other black holes. As stated earlier in the video, dark matter accounts for 80% of all matter in the universe, although it has never been observed or measured in such large quantities. On the other hand, black holes have been detected, and we even have a photograph of one to verify their existence. Natarajan Nico Capuletti of the University of Miami and Gunther Hassinger of the European Space Agency investigated the hypothesis of primordial black holes, trying to figure out how they may explain dark matter and perhaps other cosmological puzzles. By looking for the first stars, galaxies, and supermassive black holes, they discovered that the primordial black holes might play a significant role in the galaxy, SMBHs. Primordial black holes must be within the specified mass range to pass present observational tests. In their latest study, the researchers hypothesized that the primordial black holes had a mass of roughly 1.4 times that of the Sun. They built a model of the universe in which all of the dark matter was replaced by these relatively light black holes, and then sought observational evidence to support or refute the model. They also stated that their findings suggest that stars, galaxies, and SMBHs arise very swiftly in cosmic history, maybe too quickly to be explained by the current universe's creation and expansion processes. While this notion is merely a model, experts feel that it might be tested quite soon. They added that the James Webb Space Telescope is specially built to address questions concerning the genesis of stars and galaxies. Furthermore, the next generation of gravitational wave detectors, particularly the Laser Interferometer Space Antenna, LISA, is expected to disclose a great deal more about black holes, even primordial ones if they exist. According to astronomers, the two observatories should provide enough data to piece together the narrative of the earliest stars and perhaps the beginnings of dark matter. NASA's James Webb Space Telescope. Since we're on the subject of the James Webb Space Telescope, for those who are unaware, the James Webb Space Telescope was successfully launched into space after so much uncertainty around it. The James Webb Space Telescope, often known as JSWT, or Webb, is NASA's most advanced and biggest space scientific telescope. The telescope is an infrared observatory that orbits the Sun around 1 million miles from Earth in order to detect the first galaxies and witness stars forming planetary systems in the early cosmos. With longer wavelength coverage and considerably enhanced sensitivity, the James Webb Space Telescope will complement and expand the Hubble Space Telescope's discoveries. It is a renowned observatory with a huge infrared telescope with a main mirror of roughly 6.5 meters. The Webb will investigate every stage of our universe's evolution, from the first brilliant glows after the Big Bang, through the birth of solar systems capable of supporting life on planets like Earth, as well as our own solar system's evolution. The Webb was launched from Europe's spaceport in French Guiana, and on the northeastern coast of South America, on December 25, 2021, using an Ariane 5 rocket. The Ariane 5 was provided by the European Space Agency, and the mission crew ignited Webb's thrusters on January 24, 2022, to place the telescope in orbit around the Sun at the second Lagrange point, or L2. One of the goals is to go back 13.5 billion years in time and witness the earliest stars and galaxies that formed a few 100 million years after the Big Bang. The telescope will largely study the universe in the infrared, whereas Hubble has studied it predominantly at optical and ultraviolet wavelengths since its debut in 1990. Webb has a far larger light collecting area than Hubble, allowing it to gaze at longer distances and hence further back in time. The James Webb Telescope team just finished the third of 7 planned phases to align the 18 segments of Webb's large mirror on February 25, 2022. The researchers revised the placements of Webb's primary mirror segments and altered the alignment of the secondary mirror during the second step, dubbed the second alignment, to bring the 18 individual pictures into focus. The 18 pictures were then layered to create a single image. After future alignment steps, the image will be even sharper. NASA officials stated in a statement, when it comes to recent developments on the Webb Space Telescope, the Kuiper Belt and quasars are the two key priorities for now, and they are both close in astronomical scales, and far enough that Webb will explore to better understand the universe. First, there's the Kuiper Belt, which is home to frozen objects left over from the solar system's inception. Some of Webb's first missions will be to view dazzling quasars at the centers of distant galaxies to research how these faraway objects, driven by black holes billions of times the mass of our Sun, impacted the early cosmos, as contributing writer Elizabeth Howell writes today. The Kuiper Belt, which is home to Pluto and its largest moon Charon, will be a target for the Webb, and it is a little closer to home. Another of Webb's early research goals will be to study Pluto and other objects in the Kuiper Belt at the solar system's edge over time in order to understand the surface chemistry and why there is such a broad spectrum of objects there. What other theories are you expecting to be proved or disproved? What do you think about the James Webb Space Telescope? Let us know your thoughts in the comment section down below.